Good afternoon, everyone. My name is Kirsten Greenberg, and on behalf of Lung Foundation Australia, I'd like to welcome you to the first instalment of our webinar series for National Silicosis Prevention and Awareness Campaign. This webinar is titled Ask an Expert, Silica Dust in Mining, Quarrying and Tunnelling. Through this virtual meeting place, today we are gathering from many parts of Australia, and I would like to start by acknowledging the traditional custodians of country and their continuing connection to land, sea and community. For myself here in Brisbane, I stand on the lands of the Yagara and Turrbal peoples. I pay my respect to elders, both past and present, and acknowledge that this land was never ceded. Before we begin today, just a few brief housekeeping. Firstly, today's webinar will be recorded and made available via our website, so it can be viewed online at a later date if you can't stay for the whole duration. You'll be notified via the email that you registered with once the recording is available. Secondly, a Q&A session will be held towards the end of the webinar after both speakers' presentations. Please feel free to submit any questions via the Q&A box, which you can access in the toolbar at the bottom of the screen throughout the presentation. Please note that the questions should be of a general nature and individual specific questions cannot be answered. I'm very excited to welcome our brilliant expert panelists for today, who are Kate Cole and Dr. Nicola Branch. We'll first hear from Kate Cole, OAM, who is a multiple award-winning scientist, engineer, and certified occupational hygienist. She has dedicated her career to preventing occupational disease. Her work on silicosis prevention is shaped by a Winston Churchill Fellowship and extensive experience across major infrastructure projects. Kate is a past president of the Australian Institute of Occupational Hygienists and the former co-chair of the National Silicosis Prevention Expert Steering Committee. And she is also a member of the New South Wales Dust Disease Board. Her contributions to workplace health and safety earned her a Medal of the Order of Australia and inclusions in the COVID-19 Honour Roll in the 2022 Australia Day Honours. Kate is a PhD candidate at the University of Sydney, researching respirable crystalline silica exposure in tunnel construction workers. We are so pleased to have both of your expertise in the room today, Kate and Nikki. So without further ado, I'll hand over first to you, Kate. Thank you.
Okay, so today I'm going to be taking you through silica dust in tunnelling and share a bit of my experience and what it's like, and most importantly, ways that you can protect yourself. So firstly, I'm sure you've all heard this before, it's just dust, right? So when we see activities in construction, building, roadworks, demolition, stonemasonry, or tunnelling, we normally see dust as well. And it's become quite commonplace to see dust in these types of industries, but that doesn't mean that that dust is harmless. In fact, it's quite the opposite. So I'm going to take you through a high-level awareness package on silica dust today in tunnelling. And it was originally developed by the Air Quality Working Group of the Australian Tunnelling Society that I led back in 2018. But it's still very relevant today because it's helpful in explaining the risks of silica dust, where exposure is high, and most importantly, how it can be minimised and how you can keep yourself safe. So one of the hardest things to hear is the doctor tell you that you have an incurable lung disease. Absolutely. Tunnel workers have an increased risk of developing many diseases compared to those in the general construction industry. And the biggest ones are silica-related diseases like silicosis. And that's why preventing your exposure to respirable crystalline silica, or what we call commonly silica dust, is so incredibly important. So broadly, cutting into quartz or crystalline silica containing materials like sandstone or shale or concrete creates dusts and silica. So high risk or very high risk tasks in tunnelling include, well, first of all, just tunnelling in general into rocks like sandstone and shale, but it also includes shotcreting, including using the wet methods that we do. It includes drilling and grouting, cutting into concrete, and things that happen all the time, like heavy plant transporting spoil. It also includes things like loaders picking up and moving spoil around that might be in a spoil shed, for example, and really common tasks like relocating ventilation. So in tunneling, obviously most things are underground. So it's actually what you can't see that is the biggest problem. So silica dust is really small. It's more than 15 times smaller than a piece of human hair. So it's very difficult to see it underground. And because it's so small, it can stay suspended in air for many hours after the larger dust particles have settled out. And because it's so small, it can reach the really tiny parts or the alveolar regions of our lungs. And we know that overexposure to silica dust can cause or increase the risk of many diseases, and they include silicosis, chronic obstructive pulmonary disease, and lung cancer, for example. So silica exposure can come from anywhere, even from clothes, covered in mud that are washed. So it's not just cutting at the tunnel face that we focus on. We have to focus on, in fact, anywhere that dust can be created or liberated throughout the workday. So I mentioned that we can't see it, and really it's what we can't see that is the problem. It makes it quite challenging. And some work groups will need to use things like ventilation and dust suppression or respiratory protection or masks in areas where it doesn't even look dusty. But it's really important that we always follow site rules on dust control, even if we don't see the dust, because those rules and processes or safety processes are there for a really important reason. So I mentioned overexposure can cause a lung disease known as silicosis and lung cancer. And we're really familiar with silicosis from the media and the latest regulations around the ban on engineered stone, which was so incredibly important. But it's not just the engineered stone industry where this is a risk. In fact, this is also a risk in many industries, including in tunnel construction. Diseases like silicosis and lung cancer have no cure. The symptoms include things like chronic dry cough and shortness of breath with exercise. And in tunneling, silicosis usually results from a chronic sort of lower level of exposure over time, but there are other forms which can be fatal within months as well. These diseases are typically diagnosed through health monitoring, which includes lung function testing and X-ray, and in some cases, a CT test as well. And diseases like tuberculosis and rheumatoid arthritis are more common in people with silicosis. And even after sort of removal of exposure from tunneling work, like finishing work in the tunneling industry, silicosis can still progress. So at the Australian Tunnelling Society, in the Air Quality Working Group, we came up with around 7 golden rules. But of course, when you're working in tunnel construction, there's many more systems and processes that are in place to keep workers safe, but these are the high-level 7 rules that are recommended. So the first one is around minimizing dust generation. So considering how the actions of one work group will impact on the exposure of another. So maybe the simplest example is when mucking out with an excavator, thinking about, well, how is this sort of dust generating work going to impact somebody downwind of me, where the ventilation may take the dust that's generated from this activity down to another work group, and what can I do to prevent that? The next one is ventilation. And of course, while most areas underground are ventilated, they're not all ventilated. So we only work in ventilated areas and we don't access areas that aren't. Working to keep dust extraction as close to the face or as close to the source as possible is absolutely crucial. And keeping in mind that if ventilation is reduced or if it's turned down for any reason, then that means we're really going to have to up our controls in other ways. So it might be the need for really high grade respiratory protection, for example. I've worked in tunnel construction for 25 years. In hindsight, I wish we had the focus on reducing exposure that we do today. Another great quote from a very experienced tunnel worker. Some of the controls that we see in place or the safety measures we see in place now in tunneling are relatively new. And every tunnel project seems to get that little bit better on silica dust control, but it hasn't always been that way. But even if new technologies or new processes seem laborious or over the top, please keep in mind that generally they're there to protect your health. The cabin is the throne. We use a lot of heavy plant, underground heavy plant, and this can be a key source of exposure to some workers. So important things like keeping doors and windows shut, even when they're not in use, covering fabric seat covers with vinyl or leather to prevent dust being liberated, because dust can get stuck easily in fabric seat coverings, for example. Making sure that heavy plant is cleaned using wet methods or HEPA vacuums, and not using brushes or brooms, which would just liberate dust and silica into the air. And most importantly, cleaning mud from boots before getting in cabins, or taking them off before getting in, because that mud will dry up over time, and within that dried up mud will be silica dust. And then, of course, changing clothes and maintaining air filtration systems is really, really important. These days, we are seeing more and more cabins meeting the Australian New Zealand ISO standard 23875, which is an international standard adopted in Australia for air quality control systems for operator enclosures. And they essentially use enclosed pressurized cabins, offering greater protection. So the more that we see those types of systems implemented underground, the better we will all be. An example of the impact of dried mud on exposure is shown here on this slide. So something simple as not cleaning out the door jamb and then shutting the door to an excavator, for example, will liberate that dried mud and dust into the air of the cabin. And that dust will stay in the cabin, in this case, for up to 15 minutes. So every time the door is shut, it's 15 minutes of exposure to dust containing silica. So it shows just how important it is to keep heavy plant cabins clean. So water is wonderful. We use it for a lot of purposes. We use it for washing down equipment. We use fixed dust suppressions rather than having someone on a hose. We use misting sprays. And of course, things like wetting down blast rock and spoil before loading out, and keeping the floor of the tunnel wet are all used to suppress the dust to prevent it becoming airborne in the first place. But the challenge with silica is that silica dust is really small, so it has a tiny particle size. So if we're using water to try to capture the dust in the air, then our water also needs to be really small in size. So that's why we use misting systems rather than garden hoses or high pressure hoses to try to get silica out of the air. And that's why fine mists or misting systems are quite common. Respiratory protection is used a lot in underground tunneling. This is a relatively old photo, maybe it's about 5 years old now, of a tunnel under construction in Australia. And thankfully, more and using higher grade or powered air purifying respirators, PAPRs, which provide a greater level of protection than the standard sort of P2 dust mask. But regardless of the type of respiratory protection that's used, it will only work if it's used all the time that you may be exposed. So if you take it off to talk or drink, then every time you do that, you can be exposed to silica dust in the air. So making sure that they're not removed until going either above ground or in a pressurized cabin or in a pressurized crib room, for example, is really important. And because we use a lot of water, it can present a challenge because disposable dust masks, if they get wet, then they stop working. So we have to replace them. So wearing respiratory protection that relies on a seal around the face, like a dust mask, will only work as it's intended if there's no facial hair that interferes with that seal. And this slide just shows how small silica dust particles are in relation to facial hair. So being so small, silica will just take the path of least resistance, and instead of being breathed through the filter media, it'll just go around the side of the mask and you can breathe it right in. As I said, thankfully, we see more and more use of powered air purifying respirators or PAPRs, which don't rely on a facial seal to be effective. Your tomorrow's health is about the actions you take today. Wear your dust mask for you and your family's sake. Yeah, I can't stress how important it is, even in areas where it doesn't look like it's dusty or we can't see silica dust, that if it is signposted to wear respiratory protection, that it's worn every single time. So silica dust is small. I've mentioned this many times. It's invisible. The only way we know how much is in the air is if we measure it. And the measurement of silica dust needs to be done regularly to understand if the control measures or the safety processes in place are actually working effectively. So occupational hygienists do this monitoring. They fit pumps and cyclones to workers and they measure dust over a period of a shift. And then the filter inside that sampling media goes to a laboratory, and that's how we figure out how much dust and silica a worker may have been exposed to. And this little picture shows how much silica dust it is in relation to a 5-cent coin that relates to the workplace exposure standard, which is currently 0.05 milligrams per cubic meter over an 8-hour day. So it's very small. And it needs to be this small because of the high toxic effect of silica dust. So silica dust exposures have been measured to be more than the workplace exposure standard in tunnelling routinely. So this means that personal exposure monitoring or air monitoring and respiratory protection is used a lot. So here's a list of roles that are typically measured to be above the workplace exposure standard on a fairly routine basis. The top is supervisors. And that's because supervisors tend to get right into the tunnel face and they get right into everything because they want to see what's going on. So they can have some of the highest levels of exposures in tunnelling. The second would be back-end work crews because they don't always have the benefit of extraction ventilation at the front of the tunnel. And then obviously heavy plant operators where we don't have good pressurized cabins, road header operators that are doing mine tunnelling that can be mining into really high crystalline silica containing rock, TBM work crews as well on tunnel boring machines, in addition to general tunnellers, mechanics and fitters, electricians, shotcrete crews, and those involved in cut and cover operations as well. So health monitoring for crystalline silica happens before you start work, and then it should be repeated every year. So this health monitoring picks up any changes to your lung function and can detect early stages of silicosis and other lung diseases. Typically, the standard health monitoring for crystalline silica includes a questionnaire, a lung function test, and an X-ray. But thankfully, we are seeing more situations where there are additional investigations being performed, such as CT scans where necessary. And I recommend that you keep a copy of your health monitoring records and take them each time you go through health monitoring. So you always have your records and you can show your medical professional what the results have been previously to help track your health over time. So in summary, I'll say silica dust and silica dust exposure is very common in Australian tunnelling. There are 7 golden rules: the dust control, minimising dust generation, having good ventilation, clean cabins, the use of water, the use of respiratory protection or masks, routine measurement of silica dust, and also health monitoring. So all of these slides that I've just showed you are freely available on the Australian Tunnelling Society website under the Working Group Papers section. So they should be hopefully helpful for you to share with your teams, to share with your colleagues, to share with your mates. Use them to help communicate the risks and the control measures across to your team. And as Kirsten said, I am undertaking research in silica dust in tunnelling. So for those of you on this webinar who may have worked in Australian tunnelling, then I invite you to have your say about your experience in tunnelling and exposures to respirable crystalline silica, which is really just an opportunity to contribute to further research into silica-related diseases like silicosis in the tunnelling sector. This is from the University of Sydney, and we're looking for people who are interested in taking part in this voluntary survey about your experiences. And we're looking for perspectives from a range of people, including employers, workers, and occupational hygienists. The information collected aims to provide researchers with a better understanding of the barriers and enablers to silica-related disease in tunnelling. And you can help by following the QR code and filling out the survey, which should take between 20 to 35 minutes to complete. And there is more information about the study and the survey at this site, and participation is completely voluntary and completely anonymous. So now I will hand back to Kirsten, and I look forward to your questions after Nikki's fabulous presentation.
Thank you so much, Kate. That was a really informative and engaging presentation. It was so great to better understand silica dust in the tunneling construction industry and how workers can protect themselves, particularly those 7 golden rules. So now we're moving on to our second presenter for the day, Dr. Nikki LaBranch. Nikki is the Dust and Respiratory Health Program Leader in the Minerals Industry Safety and Health Centre within the Sustainable Minerals Institute at the University of Queensland. She oversees a $3 million dust research portfolio focusing on occupational lung diseases. Her work aims to identify occupational and individual risk factors associated with developing respiratory diseases, the rapid progression of diseases amongst dust-exposed workers, and factors critical to the development, severity, and progression of coal workers' pneumoconiosis and silicosis as well. Her newest project seeks to improve the return to work system for individuals with dust lung injuries. So I'll now hand over to you, Nikki, for your presentation. Thank you so much.
Yeah, thank you for that wonderful introduction. So I do work with the Dust and Respiratory Health Program at UQ, and we're doing a number of great things in the dust and respiratory health space. So we currently have 3 major projects that we're working on, and we are looking at the characteristics of the dust, of what's actually being generated. So the size, the shape, the mineralogy, and the surface features, and currently in surface coal mining and engineered stone. We've previously looked at the underground coal side. We're also looking at how this reacts in the lung tissue. So what dust is more hazardous than others, and can we pinpoint those factors for the health hazard? Also looking at the medical data. So are there any early indications of disease that we could look for in the health surveillance data to better inform what's going on in that space? And as the project just mentioned, was that we've got a return to work for dust lung injured workers, especially as we're detecting these dust lung diseases earlier, and with people who still have hopefully a good working life ahead of them, and how to keep them out of the dust but still give them a meaningful work. So with what we've been doing at the university with the characterization, we've found that number one, dust is very complex, and it can vary from site to site and mine to mine. So the data here is actually the underground coal mines, and I've paired the continuous miners with the main gate samples, which are typically chalk 6 to 8 just inside that in by that main gate corner. And for those, you can see that what's in the dust is more controlled by geology. So for one mine, within the mine, it's relatively similar from one area to another with little differences by cutting, but from one mine to the next, depending on where you are, what seam you're in, it can vary substantially. And there's 42 mineralogies that we've been finding, but I've only put the top 8 here. The ones of interest from a coal mining perspective, at least, is the black is the carbon, but the red is that quartz or silica dust. And that can vary substantially from one seam to the other. And even with that, what's in your cutting horizon in a mine might not necessarily be what's in that dust that's reporting to the respirable fraction. Because in that respirable fraction that you're breathing in, that less than 10 micron size, you do have selective breakage of the rock. And so we're finding, and not just my work, but overseas as well, that you do get significantly more stone in that makeup than you do carbon from the coal seam. And this mine 3 here is just one example of that. So, for everybody, something to keep in mind, that what's in the host rock and what you're mining may not necessarily be what you're breathing in the same proportions because of that selective sizing. And that size actually really does matter. And we've found that the average particle sizes do differ. And that means for the same mass of dust, the number of particles you can get can vary significantly. And what we've found is that in the studies we've done in underground coal, that can vary from 1.8 to 4.8 microns in size, which doesn't sound like very much, but when you put them to scale next to each other, that little 1.8 microns could probably fit 4 or 5 of them in that larger 4.8 micron particle. However, you need to keep in mind that this is actually a 3D problem. And so you can get many more particles of the smaller size for the same, one larger particles. And I've done the math on what would the total dust be for a single 8-hour shift. And at 4.8 microns, that's 10 billion particles. And at 1.8, that's 197 billion particles. So that's almost 20 times the number of particles for the same mass of dust that we're measuring. And those smaller particles do actually have a greater probability of penetrating deeper into the lungs, to the alveolar region that Kate talked about previously. So it is those much smaller particles that we really do want to be sure that we are capturing. And in mining, we use water as for our dust suppression. For the most part, that is the most popular method used. And it is very important that you do have the right size water droplets for the dust that you're actually trying to impact and agglomerate, and fall out of the air. Because due to the surface tension of the water droplets, the dust can actually just go around them if the dust particles are too big. So you do want those much smaller particles to be able to impact the dust. And it's, that has to do with, what nozzles you pick and the locations that you put them in to have that right droplet size. And the more that you can control this dust at the source, the more downstream benefits you have as well. So it's more useful for maintaining your stone dusting through the mine, less coal dust generated, less often you'll have to go back and touch up. As well as if you're looking to do, other processes like methane abatement, will that clog the filters faster as you're putting more dust through. Thrown in some engineered stone in here too, to have a look at some of these particles. So the black dots in the background, those round holes those are the pores in the filter that we're looking at, and those are 0.4 microns in size, just to give you an idea of just how small we're dealing with. So 0.4 microns, so less than a micron in size for those dark black holes in the background. But as you can see, there's very sharp angular particles. There's definitely a long needle-like particle here that's less than that 0.4 wide. And those small particles, especially when they're fibrous like that, can penetrate, deeper into the lungs, into the gas exchange region. So, there's a reason they've outlawed the dry cutting there for the engineered stone. So not a good idea at all, because this is what you'd be breathing in. Same for polishing too. You're seeing a lot of needle-like fibers in the polishing as well. So it's very important that you've got your primary dust controls in place to prevent them from becoming airborne, as well as using your respiratory protection for these. And so with the silica, going back to the coal mines, the other complicating factor of this is that not all silica is created equal either. What it's agglomerated with, or what other minerals are in the particles, can actually make a difference in the health hazard of it potentially. So whether that's smaller free silica particles, like in the bottom left slide, whether that's agglomerated with either coal or diesel particulate, like the ones with the black in the top left, or with other aluminosilicates, such as the muscovite or illite or other orthoclases there, which we think may actually have a protective factor on the silica from some of those clays. So there's a complicating factor too with the mineralogy with the silica as well. So something else to keep in mind when you're trying to control the dust. So on the Return to Work project, so this is a new project that started this year. It's a three-year project sponsored by the Office of Industrial Relations. And I'm pleased to say we have just hired a full-time PhD for the project that'll be helping us out there. And there's several stages to the project. So there's a literature review for the best practices. And then there'll be a range of interviews of current experiences of people covering, both mining and engineered stone. So if you are a dust lung affected worker, I'd encourage you to sign up for the mailing list if you'd be willing to be contacted at a later date. So this mailing list is just for email updates as the projects progresses, but we're happy to have input into the interview protocols if you think there's things that we should be asking people, and we will make an announcement when the subject recruitment for this is open. And of course you can unsubscribe at any time there. But I think this will be a very important project for industry, and we've got a lot of great researchers at UQ working on this as well. So Kelly Johnston, who's an occupational hygienist here in the School of Environment. We have Margaret Cook, who's an associate professor here as well, who's an occupational therapy background in human factors, and Kirsten Way from the School of Psychology as well. So it's a fantastic cross-disciplinary team to help look at how we can improve that return to work system. And we do realize that may look different from mining, to quarrying, to engineered stone as well. The other thing I'd like to make you aware of is the Dust and Respiratory Health Forum that we hold at UQ every year. And this is it's a full day of the latest research. So we have both presentations from the US and all around Australia. So we've got one, Kate actually presented last year. And this year we've got one from, Edith Cowan University of New South Wales, coming up from some of their latest dust research, as well as what we're doing at UQ. So it's a great day of research. It is free. It's in person at St. Lucia and online as well. So, and so I hope you can make it to either, to either come to the dust forum or sign up for the mailing list for the Return to Work project if you're interested. But in conclusion, from the work we're doing, so we know that dust and silica are more complex than you think, and the size of those particles matter, and that does matter for the dust control and how you treat those particles. And what's in the host rock is not necessarily the same percentages as what's in the airborne fraction. So we really need to understand what's happening with the silica from that perspective, and Kate gave some great things on minimizing the silica and tunneling, and for mining, a lot of the same things apply. So you do definitely want to minimize the dust at the source and use the hierarchy of controls to manage the dust there. So thank you very much.
Thank you so much, Nikki. That was a really informative session, and it was so fascinating to hear the various different types of dust that are evident across the different mines that you've been conducting your research on. So thank you so much. We're just going to move on to the question and answer portion of the webinar. Whilst we're going through a couple of the pre-submitted questions, please feel free to submit any questions into the Q&A box on the toolbar as well, whilst we do have Kate and Nikki here with us. First question, I guess, looking at some of the pre-submitted ones. So should we be more conservative around the amount of people we are exposing to chest x-rays or radiation in the context that the silica exposure is low in some above ground mining and the risk approach is not being supported by the regulator and instead enforcing a one size fits all?
Yeah, thanks for that. I'll take that one. So you are getting a dose of radiation from an X-ray, but for a single X-ray, that's actually about 0.02 millisieverts is what we measure the radiation in. And just to put that in perspective of what's happening, so that equates to about 7 hours of flying. So if you're a FIFO worker, you're probably getting more than that in a week and a half there, depending on how often you're flying. We also do have a background radiation level here in Australia. So you're looking at about 1.5 millisieverts per year for what you're getting. So significantly higher than that 0.02 for a single X-ray. So yes, it is a dose, but it is a very small dose in the, given that the potential benefit of being able to identify these things early.
Amazing. Thank you, Nikki. Another question we've got. So what signs in a workplace indicate that the level of dust is dangerous? What could a worker look out for?
I'm happy to take this one. Well, no dust is great, obviously, but it's important to know and to figure out if your dust contains crystalline silica. That's probably the first step. So some things you can do is if it's a product that you're using that's been brought onto a site or your workplace, then you should check the safety data sheet or the labels, which will say things like quartz or crystalline silica or silica itself. And if it does contain silica, then you really need to be following the hierarchy of control. So things like dust suppression, on-tool dust extraction. The crystalline silica regulations will probably kick in. So no uncontrolled dry processing, the need for a silica risk control plan or a safe work method statement. And lastly, of course, the use of respiratory protection. But if it's not as easy as something being brought onto your site and you're not sure if the rock or material contains crystalline silica, then I would say that resources like Safe Work Australia and indeed the Lung Foundation have some really good tools on their website where you can go and see what types of materials contain crystalline silica, and that will help you know if you are at risk of exposure to silica dust.
Awesome. Thank you, Kate. Another question we've received is, what is information that our employees should be telling us about working with silica dust? Let's go across both mining and tunneling.
I can start from mine and then I can give it to you, Nikki. How do you think? Look, I think in the areas where the silica regulations will kick in, which may or may not include mining, I guess regardless, your employer should be providing information on the risks of the work that is being performed, the controls or safety measures in place to protect you from exposure to silica dust, and the hazardous nature of silica and indeed any of the chemicals that you may be using or may be exposed to. And they need to be consulting with you on the ways that dust is controlled. If the question is more employees or work groups that are sort of next to you, then I guess it comes down to risk assessment, consultation, and communication. So understanding that the work activities that you're doing or that they're doing may impact on adjacent work groups and including those risks in the risk assessment. But again, with the introduction of the new crystalline silica regulations, it's a bit better and clearer because the uncontrolled processing of crystalline silica substances is prohibited, which means that all the focus is on the source of where the dust is generated to start with. So it minimizes the risk, if the regulations are followed, of silica dust being an issue to adjacent work groups.
Yeah, And on the mining side, they are required to do a certain number of samples per year, so they should have a decent idea of what their normal silica levels are for the different exposure groups there. One of the things I've been finding on the surface mines with some of the work I've been doing is that what one group is doing can actually be very affected by what another group is doing, on the high wall or, outside, upwind of a workshop or something like that. So just having that awareness of, as the, the wind and the dust is changing, to say, hey, let's do something about this before you are exposing that work group to more dust than necessarily, and just being aware of each other there. I do feel like the education they're getting in mining is now pretty good. So we've known about, since the re-identification of CWP, and then silica coming along with that in mining. It's been a 9-year journey for them. So it's, a bit more mature in there, and a lot more going on site-wise.
That's really interesting. Thank you both. We might have 2 more questions. So we've just had another one come through. So have they considered the exploration side of the mining industry and exposure from drilling dust and core sampling dust generation?
Definitely something to keep in mind. I myself have not worked on the that side there with the exploration drilling, but there's several things they need to be aware of, with the drilling dust there, as well as some of the potential radioactive sources or what's in the rock, especially with some of the critical mineral exploration and work going on now. I think there are a few resources out there for, I know the AusIMM's group does have something for the exploration, a handbook there, which I believe covers some of that. But it would be good to get that exploration side out there and actually get some measurements like we have for the underground and the surface mines to better quantify, what those exposures actually look like in the characterization.
Still more to be done in this space, but we're on the right track. Might just have time for one more question. We may have already answered this in the previous questions, but is there, I guess, a proximity for someone's responsibility if the work they're doing is creating dust for other workers around them? Where does that responsibility lie, and what actions, I guess, do you recommend?
I'll give it a go. Look, there's no exact distance. So again, it comes down to risk assessment, and relevantly, the new silica regulations do prohibit the uncontrolled processing of crystalline silica substances, as I mentioned. So it means that we're focusing on, or need to be focusing on, controlling the risk of dust generation at the source, wet dust suppression, effective on-tool extraction, etc. But I guess understanding that most dusts can contain crystalline silica. So if you're unsure if it does or not, I think it's safe to assume that it does. And so treat it as if it does. And so go through that process of the hierarchy of control of what can we do to stop this dust being generated in the first place? How do we capture it better? How do we knock it out of the air better? How do we separate ourselves from what's going on? Or how do we enclose the dust or enclose ourselves? Or if none of that is possible at all, how can we make sure that we're wearing the right type of fit tested respiratory protection to keep ourselves safe? Because I appreciate that the smaller businesses or subcontractors or trades that might only get on a site for half a day or a day, and you don't have really much control of your working environment at all, and you're very unsure, then being appropriately fit tested, knowing how to wear a respirator and when and where, how to maintain it, how to wear it correctly, might actually be your best way of protecting yourself from exposure in workplaces where you have no control about what anybody else is doing.
Thank you so much for both of your really comprehensive responses to those questions. So that kind of brings us to the end of the formal part of our webinar. Just like to thank everyone who is attending and for submitting your questions throughout the session. And I hope you were able to find some value in the topic that we discussed in the presentations by both Kate and Nikki as well. To you, Kate and Nikki, on behalf of the Lung Foundation Australia, it's always a privilege to listen and to learn from you. So thank you both so much for sharing your time and your expertise with us today. And to wrap up this afternoon, just like to share that throughout the month of October, the Lung Foundation is running our annual National Silicosis Prevention and Awareness campaign, where we are encouraging workers to take our Healthy Lungs at Work quiz to better understand your risks of silica dust and other hazardous exposures that you might be experiencing in the workplace, and to also talk to your GP about those workplace exposures to better monitor your lung health and overall health and well-being as well. You can find more information about our campaign at healthylungsatwork.lungfoundation.com.au. And that was all for me. Thank you so much for joining. I hope you have a lovely, lovely afternoon. Bye for now.